from the Max Planck Institute for Demographic Research in Rostock. So Ainhoa and László will present the Ainhoa, please make like that. This is Ainhoa and László, our second presenter. So László will start. And let me tell you a few words why actually we have decided to set up the short-term mortality fluctuations database. So I just share my screen and show you a couple of slides. So this one. Oh, aha. Vera, can you give me, delegate to me a possibility to share my screen? Yes, okay. So, do you see my screen? Yes, okay. So, the motivation for establishing a short-term mortality fluctuations database is exactly the following. So, if you build such a graph with different country trajectories, in the space of cumulative COVID-19 morbidity, so so-called confirmed cases, and accumulated COVID-19 mortality, then you will see a very, very diverse picture. So, for example, if you compare Switzerland with Belgium, you can see that one and the same level of morbidity corresponds to very different levels of mortality. This means that registration of either morbidity or mortality, and in fact both morbidity and mortality from COVID, is a very, very peculiar thing which differs much across countries. And in fact, countries, if one uses this most popular and most widespread information on COVID-19 pandemic, then it's absolutely misleading and confusing, because the data is not comparable across countries, and the data is not even comparable within one country for different time periods. So, and with some colleagues from with David Leon, who is present today in the audience, and with Franz Misle, with colleagues, other colleagues from the Republic, from Norway, we actually tried to promote this agenda of looking at excess mortality from all causes. And this is our first letter to the Financial Times, published on the 6th of April, 2020, and a more detailed letter with more explanation, which was submitted in the end of March 2020, but published much later. I don't remember when. I think it was in May, quite late in May. So that's why data on excess mortality from all causes across weeks is so useful and important. This is the most reliable, the most comparable data across countries. And now I am stopping sharing my screen, and I would like to invite László to continue with his presentation, and then Ainhoa will follow up. Thank you very much.
I think Ainhoa is going to start. So
yeah.
Ainhoa?
Right?
Excuse me, please.
No, it's okay. I share my screen. Oopsie. Hold on. Nope. Oopsie. Here. Sorry. Sorry about that. So, thank you for joining us today to know a little bit more about our new data collection that is called, as Vladimir mentioned, the Short-term Mortality Fluctuations data series. It's a data collection that, as Vladimir said, it collects or gathers weekly mortality data by age and sex. Already Vladimir mentioned that a little bit what was the idea behind this project. And just to repeat shortly, the aim of this data collection was to create an open and free data collection to assess the actual excess mortality due to COVID-19 pandemic. But actually, this data collection is going to provide data to analyze other kind of mortality shocks across countries and time. And let me show you this graph from France. As you can see, the COVID pandemic hit significantly in France this year, but there are other events that they also cause really significant excess of mortality. You can see the 2003 heat wave that was really, really bad in France. So this data collection will allow any researchers to analyze other mortality shocks in different countries. So to have such a database, what kind of data we needed? We wanted, at the very beginning, we wanted to get data by month, death counts by month or week. And at the beginning, we could just get monthly data, but then we saw there was this possibility of focusing and gathering weekly data. So we focused in asking weekly data because it was much more detailed and it will allow more research. We also wanted the weekly death by age groups. 5-year age groups was the desirable grouping, but we accepted obviously any other grouping. We also wanted the data by sex. As you know, the COVID doesn't affect, or we think that doesn't affect equally to female and male population. So that was an indicator that we wanted to have. And we wanted a period at least of 10 or 20 years. So we began to ask for data beginning in 2000. And the initial goal areas were the EU countries, the US, Canada, Japan, South Korea, Russia, Australia. Those were the countries where we thought we may get data, but also they were interesting because the pandemic was happening there too. And our project began basically together with our lockdown in Germany and many lockdowns in Europe, March 16, we can say. And that's also the day we began to work from home. So all the project just developed basically remotely. We began searching online first for open and free data in National Statistical Institute websites, other health ministry websites. And what we found was that basically 2 or 3 countries were publishing the data we wanted. England and Wales was the first one that we found. Afterwards, we found France and the US and the Netherlands, but there was no more statistical office publishing this data. So in mid-March, late March, we began emailing all the statistical institutes that they were our goal countries. And this is a timeline of the development of the Stmf project. As you can see, the idea was generated maybe a little bit earlier, but as the COVID was hitting the European countries, and we were beginning to know a little bit more about that. Mid-March begins the project. We begin for the data search, which is a task that is ongoing because this project is an ongoing project. We already got ready England and Wales data by the beginning of April, and this was the country example that we had. We managed to create a standard worksheet or a CSV file with standardized data. And little by little, our emailing and pressing to the statistical institutes, us together with other research institutes, of course, and institutions as Eurostat, began to be successful. So during April, we were able to gather data for Austria, Denmark, Sweden, Finland, Spain, the US, Norway, Netherlands, and Germany. Those basically all countries, except for the US and the Netherlands, that they were already publishing this data, they had no such data. So they made a big effort to produce the data and release it in experimental statistics program. As I told you, Eurostat gave a big push because they encouraged the statistical institutes of Europe to prepare this data because of the urgency of the circumstances. So Eurostat began to release a few countries already by April 29, May 1st. After that, we kept adding some countries to our data collection: Iceland, Portugal, Belgium, Bulgaria, Slovakia, France, Italy, Hungary. So basically European countries plus the US. And with all these bunch of countries, we basically cover Europe, but we also have a picture of Eastern and Western European countries and Northern and Southern European countries. So we could already see whether there was some difference on the epidemic consequences regarding to regional developments. We launched the Stmf at the beginning of June, and we keep adding as we get data different countries. We add the Czech Republic mid-June, also Luxembourg and Estonia, Scotland, Lithuania, Switzerland, and the last country on board is been Israel. You can see here in this graph the time coverage, the data time coverage of those countries that we currently have in the Stmf collection. They mostly cover the time period beginning from 2000. There are a couple countries that they cover more years and a few countries that they cover less years, but we basically have covered 20 years. And we have some countries almost ready to come soon to the Stmf collection. Latvia and Poland are basically ready. We need to make some checks. New Zealand just began to publish yesterday more detailed age grouping and up to 2020, and also beginning from 2011 instead of 2015 that they were publishing so far. And then we have a group of countries that they have available data from 2000, but they don't cover until 2020 because this is so recent that they still haven't processed the data. So we just have data for Serbia, Slovenia, Greece, Russia, and Croatia until 2018, more or less. But eventually we'll add the newer data, of course. And then you can see that there are a lot of countries missing, basically the Latin American countries and the African countries and the Asian countries. As I told you, we're actively searching for new data sources, and eventually we'll be able to include those other countries too, that they don't just belong exclusively to Europe. So where can you find our Stmf data? You can go to the Human Mortality Database. This is the main project and the Stmf is, we conceive it as a product of the HMD project. So you can get the data for free and you don't even have to register to download the data. Here in this section, you have the hyperlinks to the data. I'm going to show you later what you can find here. And you just have to go there, click and download. So it's very easy. And if you have an R script, you can weekly download automatically the data and have the newest data for your work or research. And then we have a new website that László developed. It's a visualization tool that provides different graphic options to visualize the Stmf data. And László will show you all the details about this website. But here at the very bottom, you can also download the data. So what kinds of data you can find in the Stmf? So first of all, you can download weekly death counts for all countries. You can download an Excel or a CSV file.
Excuse me. Please turn off all your microphones except the presenter. Please do it.
Okay. So when you download this file, you have a description on the first a spreadsheet, and then you have a spreadsheet for all the countries here. If you go to a country-specific the spreadsheet, you have the same structure for all countries. You have death counts by those age groups, by week, year, sex, and then some death rates that we estimated. You can also download the original raw data, which is in most of the cases by 5-year age groups and sex. So you can download it in an Excel or well, it's a CSV file. So any software program can just download it and use it. We also offer the description of the data formats and the methods that we use in the STMS. And we also provide a metadata for each country. I'm going to show you the structure of one. This is the Spanish data metadata, but every country has the same documentation. It's very concise, brief. It includes what's the coverage of the population, the time coverage, how are the weeks rearranged, if the deaths are by date of occurrence, which is in most of the cases, but we have a few countries like England and Wales and Scotland, and Latvia is coming to, whose data is by date of death registration. We also provide information of data restrictions or modifications, if there is any, data delays, notification delays, contact information of the original source, and if there is any additional notes, we also provide them. And we update the data collection every week so far. I will
excuse me, please. Excuse me, please. Please, Elena, who is using the iPhone, and Anna Safarova, please switch off your microphones.
Okay. So the last thing I wanted to mention before letting László talk to you and show you a little bit our Shiny app was our updates. We update the data collection so far every week. What we include in our updates is new weeks that they're recently released. We revise all the data for 2020 because, as you imagine, this data is provisional and very preliminary. And in many countries, well, most of the countries, the last weeks are incomplete. So every week we revise and correct all that data. if there is any more detailed data, for instance, more detailed age groups, we switch country data. For instance, we are going to probably do that next week for the Netherlands. We have 3-4 age groups now, but now it's available 5-year age groups. So we'll switch the data. And we also try to include, if not every week, every 2 weeks, new countries, 1, 2, 3, whatever it's available, and we're able to process, check, correct, and prepare. And obviously, we record all the changes and all the information that you need to know about data specifics in the metadata file. As I told you, I just wanted to highlight again what are the websites where you can get the Stmf data. You can also contact us in this email address, and you can follow or our updates or news in our Twitter account. And this is, I will be happy to answer any questions that you have. I'm open to get your feedback, listen to your comments, and I guess we'll do that after my colleague László talks to you a little bit about the new application or website that he designed. Thank you for your attention.
Yeah, thank you, Ainhoa. I will try to.
Thank you very much, Ainhoa. And now László Németh continues with the presentation.
So I hope you can see my screen. So this is a, can you see my screen? Yes, okay. So we had the idea to somehow present the available data in a graphical interface to focus on the excess mortality. So the main idea from Dima and Vladimir, so I'm very thankful for them who came to me and told me to participate in this project. So the main idea was to focus on excess deaths or death rates in response for the coronavirus pandemic. And yeah, so now I'm going to present this part of the website. And I would like to emphasize that you always have to go and read the metadata file and the methods what we have, because as Ainhoa also mentioned that some data series might be incomplete or preliminary and it will be revised. So just to show you what you, and I will show you some examples. So what you see here is the there are 3 main parts of the website. The green one, the sidebar, where you can put some input, so some variables you can change, and then in the main part, the graphs will refresh according to the input, and this is where we display the excess stats. I'm going to show you in a second, and then you can get some summary statistics in the blue area. Ainhoa also mentioned that we have maybe you didn't see it because it was smaller, that in the sidebar we have all these links to the original data, or to the data in Excel or Excel file or CSV format, the methodological note and the metadata. So and here are also on the top, you can see the project's website and the contact email I also showed you before. So what you currently see here when you open the website is a configuration to show Austria in focusing on 2020, because we are the main focus is currently on the COVID-19. So we are trying to show the access for 2020 currently we have a measure. I now showed you we have different measures. We are showing now the total deaths, the number of deaths for both female and male, and also combined populations in Austria and compare this 2020 to a reference period. The reference period, I now showed you we have different, for different countries, we have different period available data. So you can select you can select the reference period, and you can select the reference level. I'm going to explain shortly what kind of reference level you can choose. So this you have to imagine like an expected number of deaths in this case, what we would expect, and you can calculate these expectations in a different way. Yeah, so what you see here, I'm going to turn off just let's have one graph. What you see here is for both females and males combined for Austria 2020. This is the target year designated by the black curve, and the reference level is currently from we have available data for Austria from 2000 to 2019, and as a reference level we calculate the expected number of deaths as the averages in the reference period for a given week. So as you can see here, for example, for week 10, we calculate the reference level we take for each year from 2000 to 2019, we average the deaths for week 10, and then we have a reference level for week 10. We also do this for week 15 and all the years available. This is what you see here for designated by the blue curve, and the difference between the two, so the target year minus the reference level, either you see an excess mortality, which is like this yellowish color, or you see mortality deficit, that is that there are less deaths than what we, so to say, expect for this year. There are not so many. I will change some other years. So yeah, so now I'm gonna show you some, let's say, some features of this website, what you can do here. Yeah, so currently we have 25 countries in the database. I don't know if someone has some favorite countries, I can also do that. So let's select some other country where you can clearly see the COVID excess death, this huge excess mortality for Belgium in 2020, or I like to look at the United States of America because it looks like a shark. Let's see, I will put females and males. And you can see this huge excess mortality compared to the expected levels. You can also change, let's say if I go back to Germany, we don't have so long data series available, but for 2020, as you can see, there are compared to the previous countries I showed you, the excess mortality is not huge, and you can see some, let's say, mortality deficit, where in 2020, now the average is only from 2016 to 2019, so that it is below the expected level. But here I added the feature that you can turn on all the other years we have in the database, and these curves you see in the background with the gray color, it's all the other years we have available in the database. And a cool feature is that you can, when you turn this on, you can click on points to identify. As you can see, we have here an excess mortality, but there is a curve which is much higher than in 2020. So if I click here on this point, there should be an information, yeah, here on the under the figure, which I currently cannot see, that this is the data point in 2018 week 10. So if I choose 2018, you should see a huge excess mortality if you don't change the reference period. So as we can see, there was a huge excess that for Germany in 2018, but not so much in 2020. So a researcher could identify what's the reason behind this. Maybe someone already knows. And there are also other, not only for this week, but for other weeks. For this reason, if you want to maybe you've already seen, if I go to hover my cursor over the mortality excess, then you get an information that this is between weeks 6 and between week 7 and 16, and this is 10 weeks long, then 10 weeks long. So you can also check the other mortality excess, which is only 5 weeks long, but you can also do this for the deficit, which you are going to see for some other countries. Yeah, and then one more summary statistic, some basic information. If you select in the graph, let's say this excess, then you will see that, so we saw that this is between week 7 and 16. Then if you select this area in the figure, then you will get the excess mortality for the total and the female and male. So this is more than almost 25,000 deaths compared to our reference level, or you could compare to the other one. This is 4 weeks long. This is more than 6,500 extra deaths, and so on. So you could get some very basic information from the graphs itself. So this is the let's say the main features, how you can interact with the figures. But yeah, so I selected some countries or some examples just to give you some idea what kind of research you could also do with this tool already. For example, we saw. Okay, this is not a question for me. So let's say I already showed you France. And if I show you France, we can also already see the effect of COVID. And as Ainhoa said, there is another excess mortality here, which can be identified as 2003. If I click, I don't know why, yeah, 2003, and if I change to 2003, then you should see the excess of this heat wave. Yeah. Maybe I should show you other measures. So we have currently the deaths and the death rate estimated for the total population and also for some broad age groups. Let's say, let's go back to 2020 to show you some information on France. If I change to death rates, you can see that the COVID also, so the effect of the COVID on the death rates, the difference between when you display the death rates, the summary information of, I think this is week 23, okay, then you will get an average death rate. This is just the mean, the arithmetical mean of the excess mortality in this case, so it's not the sum as in the case for deaths. Yeah, but you can choose to have a look. So we already had a look for the deaths in total. So now I understand that someone is writing into the chat. Maybe it's important. I don't know. Cannot see it correctly. Anyway, so if we break down the deaths according to age groups, you can see that for France in 2020, between ages 0 and 14, there was no excess mortality. If we go to higher ages, this is a very broad age group from 15 to 64. There is also already some excess compared to the reference level. And as we go to older ages, you will see that these are the ages that are most affected by not only by the COVID currently, but also some other seasonal mortality. Yeah, above age 85. So, but Vladimir had some other idea that we could explain the expectations of, let's say, death, not only because of the COVID, but we can also see some kind of seasonality. As you can see here, this convex curve, the blue reference line, we could also, so these are the weekly averages, but we could do this for this reference period to have an expectation what would it be to average these values to let's say control for the seasonality. So if I change here for another reference level, exactly the same period, then you should see a horizontal line which equals to the average of the previous curve, and you can compare to this kind of expectation. This would be like an average value over the year. And we included another average when we exclude generally in the winter months there are more deaths occurring. So we decided to include only the summer months. So this is the summer average trend over the period. This should be generally lower than the previous horizontal line. So you can define your excess mortality this way as well. But Vladimir also had an idea to let's say what would be our expectations if we have a look at each week separately and over this period. So let's say we take week 1 from 2000, from each year from 2000 until 2019, we fit a linear trend, and we predict a value for 2020. So if we have, in this case, 25 weeks, this is 25 linear trends, and we arrive to a reference level. If I show you this one, this could also indicate that our, so according to the trend, this could be also the excess mortality defined in this way. And as you can see, this is not there is not only one way to define excess mortality. Also, there are mortality deficits. If we look at this definition, this is for a 10-week long. So as you can see, this includes, let's say that in the first weeks, in these winter weeks, the mortality is generally higher. Yeah, so let's say this is one country. Yeah, so I could show you this warning that the last weeks might not be, so they are just preliminary. If I show you the United States, you can see this, that there is a sudden drop, which we don't think that it's true. So these values should be used cautiously, and they are definitely going to be revised. but I think this is also true for Finland. Yeah, there is a sudden drop, which is unexpected, I think. Yeah, so I wanted to show you Hungary. So we've seen some countries with clear definition of this excess mortality for the COVID, but these countries are generally low. I would like to show you also England and West. So they are generally low mortality countries. Yeah, so here we can also see the clear effect of the COVID. But let's say if I go to Hungary, let's go back to total. For Hungary for 2020, the expectations are actually higher than in 2020. So as you can see, there is almost no effect of the COVID. So maybe I should show you some death rates as well. So we see some excess for females for the death rates. And if I go back to age-specific death rates, for example, ages 85 plus, these are deaths. Okay, so what I wanted to show you death rates. So we saw that there is not such a big excess, but as you can see, for ages 85 plus in Hungary, it's way below the expectations. So why could this be? So generally, Hungary has a very low life expectancy. So this is a very high mortality country. So here you can turn on an additional country. So let's say if we compare, let's not. So why this could be? Why are our expectations so high? If I identify these points, you can see here, this is in 2003. So if I choose 2003, you can see that in 2003, something was way above our expectations for the same reference period, or also I think it was 2007. Yeah, so for 2007, no, maybe this was the 2005, yeah. So as you can see, these 2 years bring the average quite high. So compared to 2020, there were some more serious flu in Hungary than currently the COVID-19. Yeah, so if I compare, I wanted to show, this is similar to in case for Bulgaria. Oh, some errors. So you can also just select an additional country, which could be the same country, to compare 2 different years if you like. But what I would like to show you is, let's say, England and Wales. Yeah, so what you see here is the deaths. As you can see, Bulgaria is a much smaller country than England and Wales. So let's compare the death rates. So the death rates, as you can see, for the total of England and Wales is somewhere between 0.007 and 11. And for Bulgaria starts from 0.14 to 0.018. So what we can see here is that the excess mortality here in England and Wales is like very similar to what we have in Bulgaria, like all in general. So all years, and so throughout the years, not only in the pandemic. So policy should or research should be focused also on this question, like how come that some countries, or like in the European Union, if there is a convergence or similarity, how could this happen? That maybe also some policy should focus on these kind of inequalities in mortality. Because this is a huge difference between the people who live in Bulgaria and people who live in England and Wales. Yeah. So, and let's say I wanted to show you Portugal and France. I also mentioned this heat wave. So you could Portugal and France. And the heat wave was in 2003. Yes, this is what I wanted to show you. So with our tool, you could compare, let's say, the heat wave. Oh, error. This has to be fixed. So you could select Portugal. So this is from weeks 31 to 34. And you could also select this for France. And you get the information below. Okay, I should have selected to the same weeks, but theoretically you can compare the excess mortality, like how much the other pandemics or a given pandemic or just a shock in mortality affects two countries. Yeah, very easily. And yeah, like one more additional feature, if you can say so, you can change the colors in the graphs. I haven't done this, but this is also possible. I don't know. I will check the chat. I don't know. Okay, I will answer. I don't know. I cannot open them right now. So I think this is pretty much the features of our visualization. What you can expect in the future, because we still have some plans. We are definitely going to update the user's guide according to the feedback, because this is what I explained you is also, you can find it in the user's guide with some examples. We got a comment from David Leon to maybe to access the data what I selected here to download directly. We are still considering it. Maybe it's better if you can download the R code, or because we would maybe prefer it if you go to the original data source and use that, just to avoid mistakes of multiple data sources. Yeah, but this is still under discussion, or maybe to include a map to visualize these rates or deaths. Yeah, but if you have any kind of recommendations or some comments, I'm happily improve anything you think worth. Yeah, and another idea Vladimir had to include not only single countries, but to include a group of countries where maybe with some predefined groups, or what you can create your own groups. But this is coming in the future. So I think that was from my side, and let's see the chat. So I don't know, Vladimir, are you gonna like go through the questions or should I read them? And
okay, so you finished, yeah?
yeah.
Okay, so let me, yeah, let me now switch to some questions and comments from the chat. And after that, we can, perhaps you can add more comments and questions, and also will be a possibility to ask a question directly by indicating your willingness to ask this question in the reactions, you know, just by raising hand in the reactions. Okay, so there is a question from Yegor Kotov. I will not read the question entirely, but the question is whether we plan to add the recent data for to the database. And that's the first question. And the second question is, are we intending to use only national or country level as we do it now? Or we also want to collect or to use some information for sub-regions within countries. So who would like to answer this one? I know probably you might want to do it.
Sorry, about Russia, maybe you are more appropriate to answer the question. I mean, so far we have data up to 2018. I don't know when it's going to be available, 2019 and 2020. I don't know. I think Vladimir, you know more about that. Country level, obviously we'd like to expand the Stmf to regional level, but so far our resources just allow us to focus on country level. Once that the database is available now and it's kind of under control, we can think about expanding it, but it won't be in the short term. I mean, that's obviously it's a possibility because data is there. It shouldn't be complicated to get that data, especially the countries that they are already publishing through Eurostat. We have NATS 311 in Eurostat. Spain publishes in its Statistical Institute website by provinces, so it shouldn't be a big problem. We won't do that in 1 month, okay? But obviously, it's something we can add to the database. I want to answer very quickly to Ilya about the week definition. We basically follow the ISO 8601 guidelines, which is the one that also Eurostat follows. So that means for most of the countries, week begins in Monday, ends in Sunday, and all the weeks are 7-day weeks. But all the information details are in the metadata. So for instance, England and Wales begins the week on a Saturday and finishes in a Friday, and the US usually goes from Sunday to Saturday. But all that information, if you want to know country specific details, you can go to the metadata, and it's very easy to follow the contents. Yeah.
Okay, let me add a few words about Russia. So, well, unfortunately for Russia, Russia has not did not follow this example of other countries, and in a way that to publish or to make available weekly data for the year 2020. So I know that the Rostat and Minzdrav they are using such data in their own operations, but the data is unfortunately publicly not available. So what we are doing now, we are actually preparing data, Russian data for the period from the early 2000s up to 2018, and the data for the detailed data death records for the year 2019, from which we can make a tabulation and produce data for 2019, is also available, or will be available soon. But the data for about data for 2020, we are not sure. And that's a pity. I don't know why actually this such a political choice is being made. How to say, not to publish this data, but more or less to use it like internally. I don't know, but for 2020, if this situation continues, we will have to wait longer. So then it may be later in the year 2021. If it just goes in a regular way, you know, then we will obtain this data. I very much hope that something happens and we get this data earlier. So that's also the reasons for hiding or not publishing the data not so clear for me, because actually, as far as I know, this mortality impact of the pandemic in Russia is not so severe. It's much less than in many other countries. So I don't know why hiding that. Okay. Let me continue with questions. So there is a question from Team Riff, and it's about the following, that at the moment we have in this Stmf, we have only HMD countries. So countries with presumably good quality vital statistics. So what about the inclusion of non-HMD countries? If data for such countries is available or becomes available, even envisaging that in these countries quality of such data may be not so high. So who would like to answer this question? Ainhoa, you again, or?
I mean, I don't know if your answer and mine would be the same. I personally would go for including more countries' data. I mean, the Stmf is part of the HMD, but it's not exactly the HMD. I mean, so I mean, I think that the more countries, the more data, the better. But obviously, there are some quality issues to respect, and yeah, but I will honestly, I would like to include more countries. I think it's very interesting to know what's going on in Latin America and obviously in African countries. It's very important to know about that. So, and the only thing, yeah, the only way to know it is to include the total death data. I mean, by total death data, in my opinion. So, yeah, I don't know. I don't know what Vladimir or Dima would say to that, but
yeah, well, I'm not sure what Dima thinks, but in my view, yes, it would be useful to add data for some non-HMD countries. Well, one obstacle, and important one, is that in this particular epidemic, it has, well, I mean, within the losses, the share of very high ages is high. And usually in countries with lower data quality, data, there is some understatement of mortality in such ages like 80 plus or 85 plus. So that might be an obstacle, but I still would go for inclusion more countries. Perhaps we can place them in slightly different kind of so HMD countries in one place, compartment, or non-HMD countries in slightly different place, indicating that some concern in the quality of the data. But I would include such data because, yeah, for example, because of what happens now in Brazil or in some other parts of the world where this the pandemic has quite strong mortality effects. But also it depends on funds. If we get additional money for this work, then of course we will have a better possibility or practical, options to develop this database further. If not, then maybe more restricted activity. Then there was a comment also by Yegor Kotov that he appreciated that our database is linked to our infrastructure, and yeah, thank you very much for this. And there are comments by Dave Leon where he explains what he meant to provide an easier access to data behind the figures, to actual data in Excel format or in some widely used format for users who are not very, how to say, who would have difficulty in dealing, accessing data with R, or working with large Excel spreadsheets. So for example, to provide a part of data, a small part of Excel spreadsheet corresponding to some part of the figure on the screen. So László, what would you say about this?
I completely agree. I think this is coming. We just have to agree, like, on the final version, like what the user can exactly download. But I think it's coming. So, and to thank you for the great comments. I think I just have to mention it. So after we put this website on the final resting place, or where it can be accessed later, I think the whole repository will be open access, just for everybody to see, to control. But I think maybe it's also useful to not only just to download this selected data, what David suggested, but let's say if you want to have the graphs, I think it's also possible just to have this code, and then you can further develop what you want. So I think this is coming, as far as I see. Vladimir, you are turned off.
Yeah, just a moment. Yes, sorry. Yeah, there is as usual, Sergei Zakharov makes the most fundamental scientific comment. So say some words about the reference period. To what extent the choice of the length of the period is critical to the results obtained, and so on. So yeah, that's a very big issue. I would like perhaps to address this one. Look, this, in my view, it's more a matter of scientific research rather than the Stmf database itself or the visualization toolkit. Well, this is, I think, of course, the choice of how to estimate the expected level of mortality is absolutely crucial. So, for example, well, I'm now working on this data. I'm more or less trying to develop some scientific analysis, and I am trying many things. For example, there is a method by Euromoma, more or less, with approximation of the time series by harmonics, you know, with this sine cosine regular waves. So to thinking that these waves are parts of expected level of mortality. Then László has László has, that's a dog of mine. László actually implemented some methods for assessment of external expected mortality. So the trends, week specific trends, then week unspecific trends. So like weekly averages, and the method depends partly on the situation, on country situation. Unfortunately, in some cases, it is not possible to choose the best method, which is the best for all countries, which works equally well for all countries. For example, let me provide you a few examples. So one example is Germany. Unfortunately, Germany provides only data for very few years. So Germany provides data 2016 to 19. So, and in Germany, there was a huge epidemic in, as László said, in 2018. So if you make an average of all available years for Germany, the recent years, the 4 years, 16, 17, 18, and 19, then at least 2 years are quite abnormal, because there was also an important epidemic in 2017. So you see, so perhaps we should remove these abnormal years from the averaging to get a more reasonable, how to say, expected level of mortality, because otherwise the past epidemics, and unfortunately the epidemic of 2018, you can see it on the screen now, László shows it. It was on some of the weeks of COVID weeks of 2020, this epidemic was also important. For example, week 13 to 15, there was still some excess mortality in 2018. Then you can see another year with excess mortality for Germany. So perhaps you should exclude this year. You should filter them out somehow, or, you know. Secondly, the length of the period. If you take a very long period, it's a risky thing because, for example, in some countries like Eastern European countries, mortality is very much going down across 2000s and 2010s, and then you are at risk to, if you extrapolate this declining trend toward 2020, you are at risk to get a too low level of expected mortality. However, for Eastern European countries, there are good reasons to use trends, but perhaps for shorter period of time, use trends, because otherwise, if you just, for example, if you're averaging recent years, you will get too high expected level of mortality because you will not take into account the long-term mortality decrease in these countries and so on. So it's at the moment it looks like an art, and probably if one does a serious scientific analysis of this data, then it cannot be done within the framework of the toolkit. So people can play themselves and use different options and see what happens with how it influences the results. But to do a real scientific analysis of this data, I think people should work themselves, should decide what to do, and probably to use several methods to estimate expected level of mortality and to see whether their major qualitative results of their study would remain the same, whatever the choice of the expected level of mortality. Thank you. Sorry for being so lengthy in answering this question, but that's a really very serious question. Okay, then there is another comment by Dave Leona, who does not think that realistically it is possible to include sub-Saharan African countries because the registration is absolutely incomplete and it applies also to India. But I agree with Dave because then he says that for some states of India or some places in India, it may be possible. And yes, this is really true because for India, in a few places, registration is much more reliable. And these regions or these large cities, they have very large population, much higher than population of many countries which we have in our database, like Sweden or Luxembourg or, you know. Okay. Boris Denisov, meta data section could describe also data quality. Well, thank you. We can think about this, yeah? Okay, then Ainhoa agrees that we can
I just answered him.
Yes. Then Tim Reef to Dave Leon. Okay, he thinks that there is a hope for sub-Saharan Africa because the WHO has technical package for rapid vital registration with pools from variety of sources so that the quality may be improved this way and so on. So please read this comment by Tim Reef in the chat. By the way, the presentations and perhaps also the recording of this seminar will be available on the site of the International Laboratory for Population and Health at the High School of Economics. Okay, David Leon. Yes, okay. So there is a small discussion between Dave Leon and Tim Reef. Okay, I would propose actually now, I can give a word to Dave Leon and to Tim Reef to explain, but very briefly, please, what they mean, what they think about places like sub-Saharan Africa.
Sure. Is Dave still here?
First, Tim?
I think Dave left.
Oh,
Dave left. Oh.
Well, I remember what he said. So I guess what I was just trying to get at is that there's going to be a lot of data that will be released over the next year from sources that we're not used to receiving vital registration data from. Because there's this new technical package which was released, motivated by the pandemic, which is being rolled out now in a lot of different countries of the world. And the question is, can we use this data or not? And Dave Leon's response is, well, even if that data is usable, we won't be able to calculate a baseline from prior years to register an excess. And so I sort of was like, okay, well, let's think like an indirect demographer. Let's resuscitate Bill Brass here and say, well, why not use annual estimates from the POP division or from the GBD or somebody that puts out annual estimates for all the countries of the world and use that as a baseline to compare with. And Dave's response was, well, that will not have the same temporal granularity as weekly mortality data. And that's true. And so I don't know, I'm just trying to think outside of the box here and just think, well, if you had a time series of annual data, maybe there's an indirect method that somebody could invent to perturb it into a seasonal pattern that's plausible for a given place and time. That's just a suggestion that I can't exactly fill in for you right now, but I'm just wondering that, you know, like, probably over the next year, another 40 countries or something are going to put out this kind of data. And the question is, how can we make good use of that? And I'd like to be optimistic about that. Yeah.
Okay. Okay. So let me ask you whether, yeah, you have some questions, some additional questions or comments to participants. László, can you switch off the screen sharing? Okay. So no questions? No comments? Nothing? Okay, then I would like to ask the presenters to say something about this Stmf and what would you like to say in the end?
Well, no, I just thank you for all the comments and suggestions, and that we'll take them all into account to improve the database, to make it bigger and better, and to keep providing free data for any user. And yeah, I mean, we have a lot to think about, to discuss, to how to make it continue with this database. So I think all the comments and discussions are very welcome. Thank you.
I'm really happy for the positive response for the visualization, but I would be also appreciating some critical comments. So if you have any kind of, I don't know, that you don't like this functionality, or you could imagine something better, then please feel free. So thank you.
I myself have a critical comment. László, is there any news about this interruptions? You know, what I mean, if one works with the visualization and for this or that reason has to stop working, I don't know, for 10 or 15 minutes because there is an urgent email to be answered or something. And then the server actually disconnects, so your connection to the visualization toolkit stops. But when you resume it, it's very easy to resume it by clicking on it and so on. But when you resume the work, it shows you Austria, and if you made a lot of choices, you know, how to calculate expected mortality or what period of time do you want to use and so on, all this disappears. So is it possible to do something about it, to store these settings somewhere and when you start working again, that you can get back to your former choices.
Yeah, I think it's definitely possible. We have to. I think we have to just say, look at the what's to talk to the IT to what kind of technical background do we have. Otherwise, I think we can also implement it in some kind of form, which might not be supported by the Shiny by itself, but somehow we could definitely put some kind of simple form to continue this.
So am I right that this depends on the IT of the Max Planck Institute?
No, not really, because so there is a feature for Shiny to bookmark everything, but I don't think that it's supported by the hosting environment what we currently have from the Max Planck. So because we have this plan with the Shiny apps.io, I don't think that this feature is implemented in by the R group itself. So we can do some alternative bookmarking, which so if you figure out like what kind of, let's say, to download, or I can give you like a number and then you can type this number again, you know, just to, but yeah, I mean, there are ways to overcome this issue.
Okay. Okay, thank you. That's pretty clear. Okay, so, but please be prepared that at this very moment, when you use this database and if you stop using it for, I don't know exactly how long, 15, 20 minutes, then your choices, previous choices will disappear and you will have to do them, to make them again. Okay, so is there any comment by the High School of Economics organizers of this meeting? Sergey Timonin, do you want to say something? Where are you actually?
No, I'm here. Yeah, I would like to thank everyone for participating and presenters from Rostock for making a great presentation. Thanks a lot.
Okay, thank you all for your interest to this seminar. It was nice to see your familiar and new faces. And thank you, the presenters, for the great presentation. And once again, be informed that the presentations themselves and the visual record of this meeting will be available on the site of the Laboratory for Population and Health at the High School of Economics. Thank you very much for joining this meeting and see you again at some other meeting. Bye-bye.
Bye.
Bye.
Bye.